Hello, this is Dr. Varnali Ghosh Saha, scientist and professor at SN Bose National Center for Basic Sciences, Kolkata, India. I will be talking on engineering solid-state perovskites as new generation detectors. Being an experimentalist in condensed matter physics and material sciences, nanoscience, and nanotechnology, myself, along with my research group, while focusing on basic science based research, we also do application driven research for technology commercialization of the product. Today, I will be focusing on technology commercialization, deeper development related work from research lab, how one can go from research lab to industry. This is a DST sponsored technical research center project. Main motivation of this project work was making us effective in the innovation space. The primary focus is on healthcare, environment, material industry, etc. And here the main motivation is make the output relevant to the societal needs in addition to its value in commercial space. We aim to investigate some of the important science as well as multidimensional application potentials of solid-state perovskite materials by tuning various parameters and to make an attempt towards translational research utilizing novel application potentials of them. Now, to engineer properties of materials, one should have ability to go defect-free pure material with proper composition and stoichiometry, and also ability to modify properties of electronic materials in a controlled and reproducible way, that is the engineering by number of enabling tools and stimulus. And then one has to do the theory and simulation for understanding the underlying phenomena, and materials can be any type like elemental, binary or complex. Today we will show how a perovskite material can be engineered in such a way so that it can be applicable as highly radiation resistant gamma ray detector. What is the state of the art of this material? A proof of concept has been established towards cost effective room temperature, highly radiation resistant solid state gamma ray detector using solid state perovskites. Now the question is, what is the necessity of radiation detectors and what are the related issues? There are several areas like nuclear imaging, cancer therapy, security checking where needs radiation detection just as a quick tracer of the presence of the gamma radiation. In most cases, detection of gamma ray photon is done only by conventional energy resolution technique, which requires special arrangement of gamma spectrometry and nuclear instrumentation, which are not easy tool for rapid detection. So we have used a deviated approach for gamma ray detection, not only by energy resolution technique, which is a very complicated. Rather, we have used a electrical readout based method, which is a room temperature, and where we can measure at room temperature using this perovskite as a quick marker of gamma radiation. And detection technique would be extremely useful in radiation prone areas in a cost effective way where fine energy resolution is not a primary concern. And here we are showing this is a material which is used for gamma ray detection. It is put under the within the gamma ray chamber, and we put bias on it and we measure the detector current, and we have plotted the detector current as a function of time, and we see that as we increase the voltage, thus gamma ray detector current is increasing. We have used cobalt 60 gamma ray source with 1 kilocurie activity, and we have plotted this detector current as a function of voltage, and this is showing the curve. So we have used a solid state perovskite single crystal material which has been grown in our lab by wet chemistry route, and it is a 4 millimeter size, and it is basically a ABX3 type perovskite structure where A is any organic or inorganic cation, B is 4 group metal, and X is anion. And we have seen by after using this material in the under the radiation source, we have seen this solid state detector shows excellent structural and mechanical robustness under high energy gamma ray with sufficient long exposure. And we have compared with the existing materials which are being used for the gamma ray detector. Our detector is very good compared to the others, and this mobility lifetime product is very good value, and which is which shows the quality of a detector. Finally, I would like to thank to all our group members, thanks to our technical staff of our center, and thanks to Department of Science and Technology, Government of India for funding, and the facilities of our central equipment facility, and UGC, DE, CSR equipment facilities at Kolkata. And ultimately, finally, I will thank to Science Father and International Design Research Award Group for the prestigious award. Thank you all for your attention. This is my students and all the scientists group.